Assalamualaikum warahmatullahi wabarakatuh. Today, me, Wan Fatimah Atika binti Wan Arid, and my two friends, Nurul Aina Shahira binti Khairul Nizam and Nur Shazwan binti Azhar, will present about our project, Methanol Synthesis. First, we will start with the introduction. Methanol has a chemical formula of CH3OH. It is a colorless, volatile and flammable liquid, and it is very harmful for human consumption. There are many uses of methanol in our everyday life, such as plastics and paints. Methanol also being used as vehicles and ship fuel. Methanol is being blended with gasoline to produce methyl third butyl ether, or also known as MTBE. Methanol also used as a feedstock in petrochemical industries. Methanol is produced from the conversion of syngas or synthesis gas by steam reforming process. Next, I will talk about the market study of methanol. The market study is taken from Markets and Markets 2020. The infographic show you the global methanol market trends. First, the market size in 2020 was estimated to be 20.4 billion, and by 2025 it is estimated to reach up to 26.6 billion USD. The main driving force for methanol market are from automotive and construction industry. Methanol have high demand from petrochemical industries in Asian Pacific countries such as China, Korea, and Japan, as well as from South America, which lead to the growth of methanol market. China is the biggest economic driver for methanol, as they use methanol to olefin or methanol to propylene technologies that are very high economical due to high demand of polyethylene and polypropylene. Methanol also have a growing demand in marine industry due to its environmentally friendly as a ship fuel compared to the conventional marine fuel.
I will proceed with the process description of this project. As you all know, methanol is the simplest alcohol and has high volatility and flammability. In the past, in order to produce methanol, they used non-renewable source, which is natural gas. Due to the expensive supply source, the alternative way to produce methanol is by converting the synthesis gas using steam reforming. In this project, the fluid package used in Aspen-Hysis is Peng-Robinson. As you can see, synthesis gas consists of hydrogen, nitrogen, carbon monoxide, carbon dioxide, methane, and water. Firstly, the synthesis gas will undergo two stages of compression system, which has intermediate cooler in it that need to be compressed until the pressure meets 110 bar. The reason we use two-stage compression system is to improve the efficiency of this process, which can lowering the operating cost and have better reliability that can perform less chances of overheating with the presence of the cooler. Then, the stream will enter the feed effluent heat exchanger called recycled gas stream to increase the temperature until it reaches 145 degrees C. The gas is then heated in the reactor preheater until it reaches 150 degrees C before entering the equilibrium reactor. In the reactor, there are two reactions occurs, which is main reaction and side reaction. For the main reaction, it produces methanol, and the side reaction, it produces methanol and water. This reaction is an exothermic reaction because it releases energy. Then, the stream that leaving the reactor enters feed effluent heat exchanger for the second time to lower the temperature before entering the separator. The result of the lowering temperature is a vapor that condenses in the separator will then leaving in vapor state. Small fraction of synthesis gas, which are inert methane and nitrogen, will be vented off. A flush tank is used to remove the light component to prevent the build of inert component and blanket the condenser. Last but not least, the liquid will then pump to the distillation column to separate methanol and water. The required composition of liquid methanol in this project is 0.989. Next, this is our process flow diagram. As you can see, there is red line in our PFD that's showing the beginning of the process until the reactor. As I explained before in the process description, synthesis gas will undergo two stages of compression that have intermediate cooler in it and enter the feed effluent heat exchanger to increase the temperature. The reactor preheater is used to increase another 5 degrees C of temperature before entering the equilibrium reactor. The stream that leaving the reactor is then enter the feed effluent heat exchanger for the second time to lower the temperature before entering the separator. Some of the synthesis gas, which consists of inert methane and nitrogen, will be vented off. For the process specification, this is our stream table. The stream table shows the temperature, pressure, vapor fraction, mass flow rate, mole flow rate, and molar flow rate of each component. As you can see, there is some change of temperature and pressure in stream 1, stream 2, stream 3, and stream 4. For the stream number 1 and stream number 2, it undergoes the first stage of compression, which results the increasing of pressure from 51.2 until 75 bar. When the pressure increases, the temperature will increase too. To prevent the overheating process, it is then be cooled in the cooler until the temperature reaches 38 degrees C, and then being compressed in the second stage of compression until the pressure reaches 110 bar. As shown below, there is no change of mass flow rate and mole flow rate in stream number 1 until stream number 8. It is because there is no reaction occurs. The mole flow rate in stream number 9 started to change because there is reaction occurs in the reactor.
My name is Nur Shazwan binti Azhar and I will present about the chemicals that we use in our simulation. This shows our simulation that we have made up until the reactor. The chemicals that we use is hydrogen, nitrogen, carbon monoxide, carbon dioxide, methane, water, and methanol. This shows the mole fraction that we use, and then all of these components is fed into our process at 11,450 kilomole per hour. In this production, there is two reactions that involve, which is the first reaction is the reaction between carbon monoxide and 2 mole of hydrogen to produce a methanol. We use basis activity coefficient at the vapor phase. Next, the second reaction is reaction between carbon dioxide and 3 mole of hydrogen to produce methanol and water. We also use the activity coefficient as a basis and at the vapor phases. For the fluid package, we use Pan-Robinson as our fluid package. The information about fluid package I will explain at the next slide. Next is a fluid package. We use a Pan-Robinson in all units of the process for the production of methanol synthesis. This model is chosen because it well suited for the vapor-liquid equilibrium calculation. It also applicable for over wide range of conditions. The condition temperature and pressure range of Pan-Robinson are greater than negative 271 degrees Celsius, while the pressure is lesser than 100,000 kilopascal. For the Swaff-Reddick-Kong SRK, the temperature and pressure range conditions are quite narrow compared to the Pang-Robinson, which is greater than negative 143 degrees Celsius and the pressure is lesser than 5,000 kilopascal. Therefore, for this methanol synthesis production, we use Pang-Robinson over the SRK fluid package. Okay, for our simulation, we use basis in the simulation is activity coefficient. Therefore, there is a binary coefficient before estimate and after estimate. There is a change composition in nitrogen, water, which is before estimate is negative 0.31560, and then it become negative 0.69648 after estimate. And there is a change also at the carbon dioxide, water 0.04450. It is before estimate, and it become negative 0.12155 after estimate. For the other component, there is no changes after the estimation. Okay, product specification. Our desired product is a methanol. It is clear liquid with a chemical formula CH3OH. It also known as a methyl alcohol. The boiling point of methanol is 64.7 degrees Celsius and its melting point is negative 98 degrees Celsius. It is flammable liquid with a faintly sweet pungent odor similar to ethyl alcohol. It also explosive and poisonous to all humans. There are many ways to produce methanol, such as through biomass, fuel gas, and synthesis gas. For this project, we use methanol by synthesis gas, and the desired product is a methanol in liquid form. The liquid methanol produced at the end of our production is specified to be 0.989 mole composition.
Lastly is the conclusion for the first part of the project. Methanol is being used widely in automotive, petrochemical, marine and construction industries. The fluid package chosen for the project simulation is Pang-Robinson, and the simulation for the methanol synthesis has been done up to reactor in this first part of the project. Methanol has been converted from syngas in the reactor, which have a mole fraction of 0.0698. And lastly, to achieve high conversion of methanol, the optimum design of reactor and distillation column as well as recycle streams are required, and this will be proceed in our second part of our project. Thank you. That's all from us.